As you can see by the title, we're going to be talking about radar. Now we're going to learn about Doppler radars, what they do, how are they different to normal radar, and the products of Doppler radar. So first of all, we have to understand what a Doppler radar looks like. So this is what a Doppler radar actually looks like. We have a structure at the bottom, and then we've got that big sort of ball on the top. Now, what makes Doppler radar different is it has a product which is called velocity. Now, before we talk about velocity, we're going to be talking about how these actually work. Now, we can understand this through a simple diagram. So say this is our Doppler radar. We've got the ball on the top, and we've got the frame. So I'm just going to title that Doppler. Okay, so that's our Doppler radar. Now Doppler radar spins, and as it does that, it shoots out beams to see what's going on. So these beams measure a few different things. Now one of these is reflectivity. So say this is our cloud and it's producing light rain, okay? These beams which go out will only be able to reflect a little bit back because there's only little amounts of water in the air. Now if we take something like heavy rain, so say there's loads of little bits of rain on this storm, we can see lots more reflectivity. More of the beams are actually firing back towards the radar, and this is how reflectivity is measured. Now we can also use this to show velocity. So once again, these beams are shot out by the radar, and velocity is pretty much just how fast a thing, so like a cloud, is moving away or towards the radar. So most of the time the clouds are moving, say, 30 miles an hour away or to a Doppler radar. But what velocity is mostly used for is for tornadoes. So if you've got a really strong thing that's moving 120 mile an hour the other way, but then 120 coming the Doppler radar way, the only thing that it can be is a tornado. So if I draw out a tornado, so this is a tornado, and the beams measure that side, and that's 120 miles per hour moving, say, away from it, and this one's moving 120 towards it. It means there is most likely a tornado. So I'm going to show you what this looks like actually on radar. So this right here is known as a TVS, or a tornado vortex signature. Okay, and we can see, so the Doppler radar was located right there, and it was shooting out beams like that. This sort of red section here is moving really fast towards the radar, but this right here is moving really fast away from it, and that's how, if you see something like that on velocity radar, you can probably presume it's a tornado. But there's another way to double check that this is 100% correct, and that is the correlation coefficient, and this is how it works. Now then, correlation coefficient works similarly to the velocity. So once again we have the Doppler radar, and it shoots out these beams. Now what correlation coefficient actually is to say you've got a storm producing some rain, the particles that are coming down, the rain particles, are going to be a similar storm. Now if you get a tornado and it's lofting debris, you could have things like chairs, things like coins, you could have, the variety of different sizes of stuff is very changeable. So it measures how similarly the shape and the size of the things falling are. Now these can also come up from hail, because if you can imagine hail, so say this as a cloud, it's actually a really bad cloud. Let me do that again. There could be a big bit of hail here, smaller bit of rain, another bit of hail down here, and they're all different shapes and sizes. So once you look at that velocity to see the gate-to-gate shear, as it's known as, or the TVS, the tornado vortex signature, you can also say the correlation coefficient, and if it looks anything like that with the sort of blue circle, you can almost 100% guarantee that that is a tornado. Now, I hope this video helped. If it did, it would be greatly appreciated if you could subscribe, leave a like. Thank you so much for listening. Bye bye.